Hi everybody, Mrs. Jennings here. Happy Friday to you. Hope the week has gone well. We're looking at trapezoids and isosceles trapezoids and mid-segments today. And after today, we're just going to have kites left, and that will be the end of our quadrilateral unit. So as we get started, we're looking at a rhombus. Lots of things, hopefully from yesterday, from Tuesday, that we remember about that rhombus. So we're noticing on our picture that we've got all the sides are the same. We've got diagonals that are going to bisect each other. So we can go ahead and make that marking on there. And we know that when they bisect, they're not going to be, again, the diagonals are not congruent to each other, but they do create those right angles. All right, so this next one down tells us that B to D, the whole length, is going to be a 30, which means that each piece would be equal to a 15. Okay, and then it tells us that A to C is going to be a 40. Okay, so if my whole thing, right, all the way across, that gets me a 40, well, then again, each piece is going to be a 20. All right, so what is the length of each side rounded to the 10th place is needed? Well, anytime you see a right angle, you're probably thinking Pythagorean theorem at this point, for better or for worse. So let's go ahead and start with that. All right, so as I look at my triangle, right, if I just choose this one, I would have 15 squared plus 20 squared, and that's going to be equal to, on my particular triangle, that would be B to C squared. That's what we would be looking at. So 15 squared, pretty sure is 225, but let's be sure. Yep. So 225, 20 squared is going to get us a 400, and that's going to be equal to my side lengths squared. All right, so if we go ahead and combine those, it's going to get us 625, which is equal to BC squared. And then if we take a square root of that, it should come out to 25. All right, so we know that each one of our sides should be 25. Right, just by definition of a rhombus. Okay, then it wants to know, so our next question, we are supposed to figure out the measure of angle B to C to E. Well, if this were a square, that'd be pretty easy, but it's not a square. So somehow I've got to figure out this angle up here. Now again, the rhombus isn't going to help me. I don't know anything about that, but I do see a triangle. So again, if I go ahead and break this out, all right, so I'm going to call, again, I'm just going to take this triangle up here and just tilt it. So BCE, right? We know this is 20, this is 15. This guy over here is a 25. I know I've got a right angle, and our goal is over here. Okay, well, if I want to find an angle, the only thing we have to do that is trig. So again, we're going to remember here SOHCAHTOA. We have all three sides. So it doesn't actually matter which trig function you want to choose, right? Sine, cosine, or tangent will work because from angle C, I have all three side lengths, so it doesn't matter. So let's suppose we go ahead and choose sine. Just, it's first, that's the only reason I chose it. I would have sine, okay, first three letters of the angle I want is equal to opposite. So from C, the side that does not touch is B to E. That would be 15. Over the hypotenuse. The hypotenuse is always the one that's across from the right angle. So that's my equation. Sine of the angle is equal to that particular ratio. Now, if I want to get the angle by itself, I have to undo sine, which means on your calculators, we have to use the inverse key, right? You're looking for that -1. I keep the fraction just like it is. So on mine, all right, as we look at this, I would do second and sine. It's the same on the little red ones. It's the same idea. You're going to use your second key and whichever trig function you want. We make sure we divide by the fraction exactly as it was written. And so angle C should come out to 36.9 degrees. Again, we're allowed to round to the tenths. Then it asked, what's the measure of angle CBE? Well, that would be the other side. Okay, so at this point, you've got a couple options. You could do a trig function again, right? So you could absolutely run another trig function and go ahead and find it. And sometimes if you're not so sure about your answer, that's better, because then if you made a mistake here, like you'll figure it out real fast when you do your trig for the second angle. But you could also remember that your triangles add up to 180, and so you could just subtract. Okay, so if I take 180 degrees, we get rid of that 90, and we get rid of what we just found, 36.9, the measure of angle CBE should be equal to 53.1. All right, so either way is going to be perfectly fine. All right, so as we get going today, we're going to be looking at trapezoids. So if you want to grab the notes that I left for you, we're going to notice that we've got two types. Non-isosceles, or just trapezoids, and then isosceles. Only difference is on isosceles, just maybe as you would expect, right? If I told you had an isosceles triangle, you would know that you had two sides that were the same. Same thing on a trapezoid. All right, so remember that we call the sides that are parallel, those are bases. So on a trapezoid, it's our first shape where we only have one set of sides that are parallel, right? Everything else so far has fallen into that parallelogram category, and so both sets of sides had to be parallel, but that's not the case with either of these. An isosceles trapezoid, though, is going to go further, and that the two sides that are not bases, they're called legs. The legs are going to be congruent, and because of that, the diagonals end up being congruent, and your base angles, okay, end up being the same. So just like in the isosceles triangle, when you have the base angle theorem, it's going to work the same for the isosceles trapezoids, that the angles at this base are going to be the same, and the angles up here at this base are going to be the same. Both shapes, again, you've got parallel lines, you can cut it with a transversal, you've still got the same side interiors, so the consecutive angles are supplementary. That's still going to hold. Same thing holds down here. It's just once I find one set, the other set's done as well. All right, so again, we've got some worked out examples for you, but I'm going to go ahead and do some on the sheets as well for your notes. So if we look at the first example, we're going to find our measurements, and we're going to pay attention to whether we have a regular old trapezoid or whether it's isosceles. So for this first guy, all I see is the notation that marks a side being parallel. I don't know anything else. So if I have parallel sides, right, there's my transversal, and so the measure of angle C, this guy up here, should be 180, get rid of 79, which should be a 101, right, because those are going to be supplementary angles, so that should be 101 degrees. And then I'm going to do the same thing on the other side. I still have my parallel lines, but here's the transversal this time. So again, the angle down here at E, they're also going to be supplementary. So 180 minus 134, that should go ahead and get me angle E, and that one should be a 46. All right, so if I travel to the one right next to it, again, I would notice I've got parallel sides, but I don't know anything else about them. Okay, whereas if I look at C and D, notice that I've got those little tick marks. So this, again, just a regular old trapezoid, these are going to be my bases. And so when I go ahead and cut them with transversals, same idea. I'm just taking 180 and getting rid of the angle that they told me, because they're same side interior. So the measure of angle Q, that should be an 89 degrees. And then again, if I cut it with a transversal, angle S has got to be 180, get rid of that 27. And there's your 153. All right, as we look down here at C and D, right, on C, not only do I have parallel sides, but notice they've also marked that the legs are congruent. Well, when it's isosceles, my work gets a little bit lighter because my base angles have to be the same. So K and, I think I cut that off, J, right, those should be the same. This one has to be 83 degrees because they have to be the same. And then the same thing's going to happen down here. M and L also have to be the same. Now to find L, right, or M, doesn't matter, same side interior, so they're supplementary. So 180, get rid of 83, should give me the measure of both of those angles. And they should both be 97. You're going to remember your degree symbols. And so we do the same thing on D. So you've got parallel sides. Again, parallel, that's marked with those little angles. And then we know that the legs are going to be congruent, so the same idea. If Y is 146, so is the measure of angle Z. That is also has to be 146. And to find the other ones, again, they're supplementary. So 180, get rid of 146, should give us those remaining angles. And so both of those should be 34. Those are kind of our most basic. All right, so let's go ahead, flip your paper over for me. I'm going to find the back of mine. All right, so second set of examples, same idea, but with a little bit more algebra to it. All right, so I'm noticing, again, I've got parallel sides, so we know it's a trapezoid. They also told me that the legs were congruent, so this one is isosceles. Which means that if the angle J is 7x plus 2, well, so is angle K, right? This one is also 7x plus 2. Then K and L are same side interior, and so I can go ahead and set up my equation, right, for supplementary angles. So 7x plus 2 plus 25x minus 14 has to be equal to 180 degrees. All right, we'll combine our like terms. So 32x minus 12 has to be equal to 180. And then if we add 12 on both sides, that should get us 192. And then our last step would be to divide by that 32. And so x is going to come out to 6, which is all well and good. But of course, they asked us for our angle measures, so we're going to go ahead and substitute that back in. So j is going to be 7 times 6 plus a 2. Which should give us 44 degrees. And if angle J is 44, so is angle K. They have to be the same. All right, so then L, if we look down here, L should be 25 multiplied by 6 minus 14. So 25 times 6 minus 14 is 136. Now, if we've done it right, 136 plus 44 should get us back to the 180, which it does, so we feel confident about our answers. All right, so then we're going to look at B. Again, they told us it was an isosceles trapezoid. Even though I don't have notation, what that immediately means is the legs are going to be the same. E to H is supposed to be 4x minus 27. F to G is x plus 9. E to G is going to be, now E to G is a diagonal, so E to G, this guy right here, is going to be a 3y plus 19. And F to H, this diagonal, is going to be 11y minus 21. And we're supposed to find x and y. So I'm going to need two separate equations, but same idea for both. So if my legs are the same, I can go ahead and set those equal to each other. 4x minus 27 is equal to x plus 9. I like to keep my variables positive. So 3x minus 27 is going to be equal to a 9. And then if we go ahead and add 27, 3x should be equal to a 36. And then if we divide by 3, should get a 12. And there's our x. Now, why? Because it's an isosceles trapezoid, right? If they had not told us that, we couldn't have done any of this math. We don't know anything. But because it's isosceles, I know that my diagonals are also the same. So e to g, 3y plus 19, has to be equal to 11y minus 21. Again, I keep my variables positive. So 19 is going to be equal to the 8y minus 21. And then we'll go ahead and add 21 on both sides. So we should get that 40 is equal to 8y. And if we divide, y should be equal to 5. Okay, so again, if it had not been isosceles, right, if they didn't tell us that and there was no notation, you're done. You just put not enough information. Okay, but because it is, I can use those properties. Okay, so here's your last one, example number 3, and this one has to do with midsegments, which we talked about, again, briefly when we were talking about similar triangles. So at the bottom of your notes, okay, you've got one more, the midsegment of a trapezoid, and all it says is that so long as you've got a segment that splits the two legs in half, that's what we call a midsegment, okay, and it's going to be, again, it's got to be in between the parallel ones, right, and it's parallel, then what we do is it's got to be equal to the sum of the two bases. All right, so E to F has to be equal to AB plus DC, whatever that length is, and then we cut it in half. All right, so if we look at our examples over here, I'm supposed to find WX, that's my mid-segment. So what we would know is that WX, the mid-segment, and again, they didn't tell me that, but here's what I know. Notice that I've got parallel sides, and I've got the notation claiming that P to S was cut in half and Q to R was cut in half, right? So I've got my tick marks over here and my tick marks over here, which means that my mid-segment is equal to half of P to Q plus S to R. All right, so I've got half of PQ is 27, SR is 39. So 27 and 39, I'm getting a 66. And so half of 66 should give us a 33. And that's going to be equal to the length of WX. All right, so our last one, same idea, we just have a little bit of algebra. So again, I'm noticing I've got parallel sides. The middle line has absolutely split my legs in half. I've got the notation to prove that. And so I know that N to P, mid-segment, is equal to half of the bases, J to K plus M to L. All right, so JK, ML. Same thing, just a little bit more algebra. So 45, that would be N to P, is equal to half of 3x plus 11, that would be J to K, plus M to L, 10x minus 12. All right, so similar to other things we've done, you are more than welcome to take the 1/2 through. You can combine the like terms. You can double the other side. So lots of options for how to solve at this point. I would probably go ahead and multiply both sides by 2 to get rid of that 1/2. Right, so these would cancel. So 90 would be equal to, and then I'm going to go ahead and combine like terms. So we would have 13x, and then positive 11 minus 12 would be minus 1. If we add 1 on both sides, 91 is now going to be equal to a 13x, and 91 divided by 13 is going to get us a 7. Which is all well and good, except, of course, they wanted us to find M to L, so we're going to plug that back in. So M to L is equal to 10 multiplied by 7 minus a 12. So 10 times 7, that should get you a 70. Get rid of that 12. Should wind up with a length of 58. Again, if they'd had units, we'd add whatever the units was, but we didn't on this one. And so that's where we'd end.